Hello, my dear children. How are you? Now, let us discuss the concepts in exercise 4.5. In the previous chapter, we have studied inverse of a matrix. By using the elementary operations, we have found inverse of a matrix. In this section, we shall discuss the condition for existence of inverse of a matrix. Okay, my dear children. Now, first concept in this exercise, adjoint of a matrix. What is the definition of adjoint of a matrix? Let us discuss now. The adjoint of a square matrix A is equal to matrix Aij n by n is defined as the transpose of the matrix capital letter Aij n by n, where capital letter Aij is the cofactor of the element Aij. You know, capital letter Aij always denotes the cofactor of an element Aij. Remember this point in the chapter matrices. Adjoint of the matrix A is denoted by ADJ, small letters ADJ, capital letter A. Here it is denotes matrix A. So this is read as adjoint A. Okay, my dear children. Now let A is equal to, let us understand this concept by taking an example. A is equal to matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, my dear children, this is a 3 by 3 matrix. Then adjoint A is equal to transpose of matrix capital letter A11, capital letter A12, capital letter A13, capital letter A21, capital letter A22, capital letter A23, capital letter A31, capital letter A32, capital letter A33. Do you remember what are these one? All these are cofactors of these corresponding elements. We have to take its transpose. You know what is meant by transpose of a matrix just by interchanging the rows and columns. So we write this first row as a first column. We write this second row as a second column. We write this third row as third column. Then this final matrix is said to be adjoint of the matrix A. Understood, my dear children? Let us take an example to understand this definition very clearly. Find adjoint A for A is equal to matrix 2, 3, 1, 4. Okay, my dear children, this is a given matrix of order 2 by 2. We are going to find the adjoint of this matrix. Given A is equal to 2, 3, 1, 4. Let us consider A11, A12, A21, A22. Because this is a 2 by 2 square matrix, we are assuming the 4 elements like this. Then we get A11. What is meant by A11? Cofactor. Okay, my dear children. So I have to close this row and this column. What is the element left here? 4. That is the cofactor of this 2. Now A12. For this element we have to find cofactor. So this is in the first row. Close this row like this. Close this row and close this column. What is the element left here? Only 1. So we have to keep minus. That is plus minus minus plus. You have to remember this sign matrix. Okay, my children. Now A21, that is first element in the second row. So we have to close this second row and this is in the first column. Close it. What is the element here left here? 3. So minus 3. Next last element 4. This is in the second row, second column. So close second row and second column. What is the element left here? 2. Understood, my dear children? Right. These are the cofactors of these corresponding 4 elements. So adjoint A is equal to, we write this one 4. This is here, not in this row. In this row we write here in the first column. These two are in the second row. We write these two as a second column. Minus 3, 2. Understood, my dear children? Right. Understood, my dear children, how to find adjoint of a 2 by 2 matrix. Okay, now remark. Again we discuss the same point here. Remember this point. For a square matrix of order 2 given by A is equal to matrix A11, A12, A21, A22. Okay, shortcut form. This is a shortcut form. The adjoint A can also be obtained by interchanging A11 and A22 and by changing signs of A12 and A21. That is, adjoint A is equal to, actually this is a given matrix A11, A12, A21, A22. Then its adjoint matrix can obtain by interchanging. See here, these diagonal elements. These diagonal elements should be interchanged. This number should be here, this number should be here. We wrote here, see that A11 we wrote here, A22 we wrote here. In these diagonal elements we have to change their sign, change sign. So A12 is there, so we wrote minus A12. Here A21 is there, here we are writing minus A21. Okay, my dear children, we can write adjoint of a matrix of order 2 by 2 easily and directly in this way. Remember this method. Okay, my dear children, right. Now, see this is theorem 1. We don't prove this theorem, just to remember this point. Okay, my dear children, as a formula. If A be any given matrix, a square matrix of order n, then A into adjoint A is equal to adjoint A into A is equal to det A into I, where I is the identity matrix of order n. Just to remember this equation as a formula. A into adjoint A is equal to adjoint A into A is equal to det A into I. Okay, my children, this is a theorem, but in the examination point of view, they won't ask the proof of this theorem. Now come to the second point. Singular matrix. Here we now define what is meant by a singular matrix. A square matrix A is said to be singular if det A is equal to 0. If the determinant of a square matrix A is 0, then the square matrix A is said to be a singular matrix. Understood, my children? Right. Now come to the third definition. Next point. Non-singular matrix. Let us define now non-singular matrix. A matrix A is said to be non-singular if det A is not equal to 0. Okay, my children, the determinant of a square matrix A is not equal to 0, then the matrix A is said to be non-singular. Understood, my children? Right. Now come to the theorem 2. Here also just we remember this point as a formula. We don't prove this theorem. If A and B are non-singular matrices of the same order, then AB and BA are also non-singular matrices of the same order. Okay, my children, just remember this point. Okay, right. Now come to the theorem number 3. Here also the proof of theorem is no need for the examination point of view. Just to remember this point. Okay, det AB is equal to det A into det B, where A and B are square matrices of the same order. This is also remember as a formula. Det AB is equal to det A into det B. That's all. That is enough. Okay, my children. Now come to the fourth point. Adjoint A is equal to det A whole square. Okay, my dear children, det adjoint A is equal to det A whole square. In general, if A is a non-singular matrix of order n, then det adjoint A is equal to det A whole power n minus 1. Okay, my dear children, if A is a non-singular matrix of order n, then det adjoint A is equal to det A whole power n minus 1. Remember, this is also as a formula. That is enough. Now come to theorem number 4. A square matrix is invertible if and only if A is a non-singular matrix. This is also be remembered as a formula or a definition. A square matrix is said to be invertible if and only if A is a non-singular matrix. and A inverse is equal to 1 by det A into adjoint A. Remember, this is a formula. In this exercise we use this formula to find inverse of a matrix. We don't use here elementary operations. In that exercise, in that chapter, we used elementary operations to find inverse of a matrix, but here we use this formula only. We don't use elementary operations. Understood, my dear children? Right. Now the concepts given in exercise 4.5 were completed. Okay, my dear children, read well, learn well the concepts before starting the exercise 4.5 sums. Now come to the exercise 4.5 sums. Question number 1. Find the adjoint of matrix 1, 2, 3, 4. Okay, my dear children, this is a square matrix of order 2 by 2. Now come to the solution part. Here we have to find adjoint of this matrix of order 2 by 2. You know the direct method. What is that direct method? This is one diagonal, this is another diagonal. In this diagonal, just we interchange the elements. We write here 1 and here we write here 4. 4, 1. Okay, my dear children. And in this diagonal elements, just we change their sign. If plus is there, we write here minus. If minus is there, we write it as a plus sign. Okay, minus 2. Here 2 is there, so we write here minus 2. Here 3 is there, here we wrote minus 3. This is nothing but adjoint of the given matrix A. Understood, my dear children, how to write adjoint A of a matrix of order 2 by 2. Now come to the question number 2. Find the adjoint of matrix 1, minus 1, 2, 2, 3, 5, minus 2, 0, 1. If you observe, this matrix is a square matrix of order 3 by 3. Now we are going to find the adjoint of this matrix. Now come to the solution part. Let us consider the given matrix A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. That is equal to, we write the given matrix. Understood, my dear children? Right. See, my dear children, you have to remember this is sign matrix. Plus, minus, plus, minus, plus, minus, plus, minus, plus. This sign matrix helps a lot in finding the cofactors of every element in the matrix of order 3 by 3. See here, serial number I wrote here, serial number, there are total 9 elements. So I am writing here in this column 9 elements, 1, 2, 3, 4. Okay, my dear children. Now in this box I am finding its cofactor. To find its cofactor, first of all, from the sign matrix, take this sign. First row, first element, sign is plus. Keep here this plus. Now we are going to find its minor. How to find its minor? Just close the first row. See here, this is first row and first column. What are the elements here left? This is called submatrix 3501. We have to find its determinant. Det 3501. Understood, my dear children, how to find cofactor of an element? You carry forward the same knowledge to the remaining elements also. Okay, my dear children. That is equal to plus. You know how to find determinant of a 2 by 2 square matrix. 3 into 1 minus 0 into 5. By simplifying these two terms, we get here 3 minus 0. That is equal to 3. This is a procedure to find cofactor of an element. Understood, my dear children? Now come to the second element. Second element is here minus 1. Second element is in the first row is minus 1. What is the sign here for second row? First row, second element minus. So keep here minus. In finding cofactor, first we have to give very important to this sign matrix. So here minus sign, keep minus. Now close that element. In which row that element lies? First row, second column. First row, second column. Close that first row and second column. What is the submatrix you are getting here? 2, 5, minus 2, 1. Is it clear, my dear children? we get this submatrix. We have to find its determinant. 2, 5 minus 2, 1. We have to find its determinant. So minus 2 into 1, minus of minus we get here plus 2 into 5. Understood these two terms, my dear children? Right. That is equal to minus of 2 into 1, 2, plus 2 into 5, 10. That is equal to minus 12. Understood how to find cofactor of an element? Remember this procedure, my dear children. Okay. Right. Now come to the third element. Third element is here 2. So what is the sign here? Plus. Keep here plus first. From the sign matrix, write here plus sign. After that, close that row and column in which that element lies. So this lies in the first row and third column. Then what are the submatrix will you get here? 2, 3, minus 2, 0. We write that submatrix here and find its determinant. 2 into 0 plus 2 into 3. That is equal to 6. Understood how to find the cofactor of an element in a matrix? So we follow the same procedure to find the remaining elements. Okay. See the cofactors of the remaining elements, my dear children. Right. Here also I wrote the cofactors of the remaining elements, 6th element, 7th, 8th and the 9th element. Okay, my dear children. I am following. We also follow the same procedure to find cofactor of an element in a matrix. So we got here cofactors of total 9 elements. Now we are going to write adjoint A. Okay, my children. See here we found cofactors. Here we found 3 minus 12, 6. Actually these are the cofactors of the first row, but we write these 3 elements as a first column. 3 minus 12, 6. Understood, my dear children? Now next 3 elements are the cofactors of second row. 1, 5, 2. We write these 3 elements as a second column, not a second row. Similarly, last 3 elements minus 11, minus 1 and 5. We write all these 3 elements as a third column. Actually, these are the cofactors of the third row. Understood, my dear children? I wrote here directly. Then we got adjoint A. Okay, my dear children? Understood? Now come to the question number 5. Find the inverse of matrix 1, 2, 3, 0, 2, 4, 0, 0, 5. Here we use the formula A inverse is equal to 1 by det A into adjoint A. Not elementary operations. We don't here use the elementary operations. We use only the formula A inverse is equal to 1 by det A into adjoint A. Understood, my dear children? Right. Now let A is equal to matrix 1, 2, 3, 0, 2, 4, 0, 0, 5. Okay, my dear children, we are going to find its inverse. To find its inverse, you know the formula A inverse is equal to 1 by det A into adjoint A. So first of all we find its determinant. So we are finding here determinant. Det A is equal to det 1, 2, 3, 0, 2, 4, 0, 0, 5. And I am expanding this determinant along the first row. We can expand the matrix, expand this determinant along first row or first column or second row or second column or third row or third column as our wish. Okay, my children. So 1 into close the row, that column 2, 5, 2, 4, 0, 5 minus 2 into 0, 4, 0, 5 plus 3 into 0, 2, 0, 0. I expanded the determinant of this matrix along R1. Understood, my dear children? Right. That is equal to 1 into 2 into 5 minus 0 into 4 minus 2 into 0 into 5 minus 0 into 4 plus 3 into 0 into 0 minus 0 into 2. Understood this step, my dear children? Right. That is equal to 1 into 2 into 5, 10 minus 0 into 4, 0 minus 2 into 0 into 5, 0 minus 0 into 4, 0. Plus 3 into 0 into 0, 0. Minus 0 into 2, 0. Understood this step, my dear children? Right. That is equal to 1 into, in the brackets, what will you get here? 10. Minus 2 into here in the brackets, what will you get? 0. Plus 3 into in these brackets, what will you get? 0. Understood this step, my dear children? Right. That is equal to 1 into 10. What will you get here? 10 minus 2 into 0 minus 0 plus 3 into 0, 0. Understood this step, my dear children? Right. By simplifying these three terms, what will you get here? 10. This is det A. We found det A. Now we are going to find the adjoint of matrix A. To find the adjoint A, we have to find the cofactors of every element of this matrix. So first element is 1, A11. I am writing its cofactor. Okay, my dear, its cofactor is 10. Understood? Sign matrix. I wrote here also sign matrix. With the help of sign matrix, we write the cofactors. Okay, my children? Right. I have already explained how to find cofactors of elements in a matrix of order 3 by 3. We follow the same procedure. We follow the same method here. And observe here. Observe these cofactors. Okay, my children? We follow the same procedure. I explained that method in the question number 2. Okay, my children? Right. Okay, got it. We found the cofactors of all the 9 elements. Therefore, I am writing adjoint A. 10, 0, 0, minus 10, 5, 0, 2, minus 4, 2. With the help of cofactors, we write adjoint A. We found det A as well as adjoint A. Now we are going to find A inverse. We know the formula. A inverse is equal to, what is the formula? 1 by det A into adjoint A. Remember this formula. That is equal to 1 by 10. Det A value is 10. So 1 by 10 is into, what is adjoint A? Matrix 10 minus 10, 2, 0, 5 minus 4, 0, 0, 2. That's all. This is the nothing but A inverse. Understood, my dear children? Right. Now come to the question number 15. For the matrix A, matrix 1, 1, 1, 1, 2, minus 3, 2, minus 1, 3. Show that A cube minus 6A square plus 5I plus 11I is equal to 0. Hence find A inverse. First we have to prove this statement. By using this statement, we have to find A inverse. Not by using this formula. From this result only, we have to find A inverse. Understood the question, my dear children? Right. So, now come to the solution part. First, we write given matrix A. A is equal to matrix 1, 1, 1, 1, 2, minus 3, 2, minus 1, 3. Without finding A square, we can't find A cube directly. So first of all, we are finding A square. A square is equal to A into A. So matrix A I wrote here. Again the same matrix I wrote here. You know how to multiply two matrices of order 3 by 3. If you don't remember, once you go to that exercise. Okay, recall that procedure. Okay, my dear children. Right. After recollecting the knowledge of multiplication of two matrices by watching the previous videos in which I explained how to multiply two matrices of order 3 by 3. See, observe these elements. I wrote the elements. A square I found here. That is matrix 4, 2, 1, minus 3, 8, minus 14, 7, minus 3, 14. Okay, we got here A square. Now we are going to find A cube. A cube is equal to A square into A. We found here already A square. I am writing A square matrix here. Into here I am writing matrix A. Again we are going to multiply these two matrices. So we follow the same procedure to multiply two matrices. Understood, my dear children? Right. So observe the elements. Okay, my children, we got here A cube, 8, 7, 1, minus 23, 27, minus 69, 32, minus 13, 58. This is matrix AQ. Now let us take LHS. What is LHS here? AQ minus 6A square plus 5I plus 11I. So in this expression we are substituting the values. This is A cube matrix minus 6 into this is A square matrix plus 5 into matrix A here plus 11 into I means identity matrix. I wrote here identity matrix. Okay, my children, understood this step? Right. That is equal to, I am writing the elements directly. 8 minus 6 into 4 minus 24 plus 5 into 1 plus 5 plus 11 into 1 plus 11. Understood the first element? Similarly, I wrote the remaining elements also directly. Okay, my children. Now, by simplifying these elements, we get here 0, 0, 0, 0, 0, 0, 0, 0, 0. Nothing but this is a 0 matrix. This is a RHS. Hence, the required statement is proved. A cube minus 6A square plus 5I plus 11I is equal to 0. From this result only we have to find A inverse, not with the help of the formula A inverse is equal to 1 by det A into adjoint A. We don't use that formula. With the help of this result only. Okay, my dear children. So from this equation we can find 11I is equal to, we are sending the remaining terms to RHS. Then they become minus A cube minus 6A square become plus 6A square plus 5Y become minus 5Y. 5A. Understood this equation, my dear children? Right. Consider this is equation 1. Now multiplying equation 1 by A inverse, we get, now we are multiplying this equation 1 by A inverse. Then we get, this implies 11 A inverse into I is equal to minus A inverse into A cube plus 6 A inverse into A square minus 5 A inverse into A. We multiplied the equation 1 by A inverse, then we get this equation. Understood, my dear children? Right. This implies 11 A inverse into I, A inverse only, that is equal minus A square plus 6A minus 5I, because A inverse into A cube is equal to A square, A inverse into A square is equal to A inverse into A is equal to I. That is why we wrote this equation. Understood this equation, my dear children? Right. This implies A inverse is equal, we send 11 to RHS, then it becomes 1 by 11. So minus 1 by 11 A square plus 6 by 11 A minus 5 by 11 I. So I am taking the 1 by 11 common factor from all the terms. Then I am writing here A square plus 6 into A. I am writing the matrix directly here minus 5I. I wrote the matrix directly here. Now I am adding the corresponding elements. Then we get this matrix. So finally 1 by 11 matrix minus 3, 4, 5, 9, minus 1, minus 4, 5, minus 3, minus 1. This is nothing but A inverse. Without using the formula A inverse is equal to 1 by det A into adjoint A, we found A inverse here with the help of the given equation. Okay, my dear children? Understood? Right.